Hello, so today we are doing this problem called adding one to a linked list, and it's basically just we get a single linked list of digits and we want to add one to the plus one, the integer represented by that linked list. So for example, we can have an integer 1, 2, 3, and it's that is represented by this linked list. And so when we add one, we get 1, 2, 4, which is of course just 1, 2, 3 plus 1, 1, 2, 4, right? And the linked list is represented in a way such that the most significant digit is at the head of the linked list, like this. And so what we want here is to implement a solution to this. Of course, one way to do it is just to convert the linked list to an integer, add one, and then just print that, right? That's fine, but it's not really probably what the ideal solution. But yeah, for linked list problems, whenever we can't find like a really good solution with pointers, we can always go for converting it to a simpler form, like here converting it to an integer and then doing the operation and then converting back to the linked list. So that's one way to do it, but the way I'm going to do it now is this way, is different a little bit. So first, let's just list the cases that may be tricky. So for a case like 1, 2, 3, that's easy. We can just add one and get 1, 2, 4. That's not a complicated case, right? But for a case, let's say like 9 plus 1, then that one becomes 1, 0. So you can see we have one more node than the node that we had before. And it gets even trickier for cases like this. For example, in that case, we can have 1, 0, which is 1000, right? Like this. There is another case where, let's say, instead it's not all this, it's maybe 2, 9, 9, something like this, plus 1. In that case, we need to add the carry to 2 here. So cases that have carry gets a little bit complicated. So this one would be 300, right? And so these are the things that we need to be careful of. These are the cases that we need to make sure that our solution works for. We can also have a case where it's just 0 plus 1. In that case, it becomes 1. So that's also fine. Yeah, but we don't have, let's just suppose we don't have a case like this. That doesn't make sense, like this, where it's 0, 0. We don't have that. Now let's think how we can do this. So essentially what we want is, for cases like this one, we don't care about, we can just have a pointer go for cases that don't have like 9, we can just have our pointer go all the way until here, and then just adds 1 to that, to the value of this node, right? That's all we care about. For cases though like 299, we want our pointer to go all the way to here, of course, because we need to change the value of this one to become 0. But we are interested in let's say there are other numbers. Let's say we have the number, just to make this more clear, let's say we have the number 11299, right? In terms of our solution, what we are interested in is just this range here, right? This range is the range that will change. It's from 2 to 9, because we will make this 3, we'll make these 0, 0, right? Those are the things that will change. And so what we need to do is kind of just find this range. And once we find this range, we can just add 1 here, and then keep progressing our I value, and then setting this to 0, and keep progressing, setting this to 0, and keep progressing until we are done. And however, if there is no carry, we can just, in this case, just set the value at G to 0, to the value plus 1, right? So that's the idea behind what we'll be doing, right? Okay, so let's code it up. So for a case like for one case that we need to be careful of is 9 plus 1 here, which become 110. So for 9 plus 1, which becomes 10, so it becomes 1 to 0. You can see we have a new node that we didn't have before. Before we had just 9. So that hints to us that we need some kind of placeholder for these cases where we have a carry that makes the number of nodes more than the number that we had before. And so for that, usually with linked list, we use this trick with dummy node that gets initialized to just to a node with value 0. And then we point the head to it, right? And then we say dummy.next is equal to head. And doing this, basically at the end, we can just check if the dummy.value is 0. That means there was no carry, right? So this is at the end. Check if dummy so we can check if dummy.value is equal to 0 at the end. If that's the case, then return just dummy.next, because we don't want to return, like, let's say for 1, 2, 3, dummy would be pointing to, we would be having 0, 1, 2, 3, but we don't want to return that. But for cases like 9 here, where it became 1, 0, we want to return dummy, right? And so return the else return dummy, right? Because there is a value in this case. So that's one thing to be careful of. And so what's the layout of our algorithm? So first, create dummy node and set its next value, its next to head, right? That's what we said we need here. And then the second thing we need to do is set pointers I and j, like we did here for this range. If for cases like this one, we would just have it here. We would just have both at the same place. And then set pointers I and g at dummy. And then 3, keep advancing j for this case until it gets to the last position, the last node, and keep setting I to the latest value different than 9, right? That's what we are doing here, because what we want is, for cases like this, we want it to be at the end like j. For cases like this, we don't want I to be at 9. We want it to be at the last value that is different than 9, so that when we add 1, we can make all the values before I equal to 0 and the value at I equal to +1, right? And so at the end, after that, we are check if g.val is different than 9. That means we are in case 1. So this is, let's call this case 1. And this here for 9, this is case 2, where we have a carry. And so that means case 1, no carry. And so in that case, just set g.val to be +1. That's what we will be doing here, just doing 3 + 1. Else, that means that j.val is equal to 9, which means we are in case 2 and we have a carry. Then what we are going to do is just keep advancing, set I to the value of I to be the value +1, right? Set I.val to be +1. And from the next node to I, right? That's what the next node to I, which is here. No matter the number of 9s we have, right? Just keep and from the next node of I, keep setting the values to 0 until reaching the end, right? So because that's what the carry does, right? Which is changing this to 3 and then keep setting everything to 0. If we had more 9, we will keep setting everything to 0. if we had another number that wasn't 9 in between, then I would have been at that number, right? And so until reaching the end, and then at the end 5, we're just going to do this. At the end, check dummy value equal to 0, return .next, otherwise return this. So that's the gist. We are using 2 pointers to determine the range that will change, and then we update according to which case we have, the case with a carry or the case without a carry. And that's pretty much it. And so let's code this up then. So here is our add one. So we need first our dummy node, so that would be dummy equal to list node of 0, and then we need the dummy.next to point to head, and then we need I and j pointers that will point to list node, so that will point to dummy. And then after that we will do while j.next, so while we haven't reached the end yet, so this time here we are doing keep advancing j until we get, so this was the step 1, here was step 1, this one was step 2, and now we are going to do step 3. And so while j, keep advancing until j gets to the end, to the last node, and keep I to the latest value different than 9. And so for that we are going to check if j.val, so if j.val is equal to so if j.val is different than 9, then that means we are the last node and keep, so get to the last node and keep I to the latest value different than 9. So if j.val is different than 9, then we are going to assign to I the value j, because it's the latest value different than 9. And then we are going to so that's the third step. So we did the third step. Now the fourth step would be check if val, if we are in the case 1 where we have no carry. In that case, just set the value to be +1. Otherwise we are in case 2 with a carry, so set I.val to be +1, and then from the next node of I, keep setting the values to 0 until reaching the end. That's what we are doing for this case. And so that would mean we are going to say I equal to I.next, and then while I, we are going to add, to make this 0, and then just keep going to the next one. That would be the end of the fourth step. Now the fifth step would be just doing, checking if dummy.val is still equal to 0. That means we are in case 1. We didn't have a carry all the way until, well, or maybe in case 2, but just we are not in a case like 9 + 1 where we have a carry until that goes to that adds another node, right? And so for that, if dummy.val equal to 0, that means we don't need the dummy node pointer, so we can just say dummy.next. But in the other case, that means we need it. We put a carry value there, and so we need to just return the dummy value, dummy pointer. And that's pretty much it for this one. So let's run it and see if all of them. So the first one, 1, 2, 3, gave me 1, 2, 4. So that's correct. I'm just printing it with this string representation here. And then for 1, it gave me 2. That's correct. For 1, 2, it gave me 1, 3. For 9, 9, it gave me 1, 0, 0. Now let's say let's do the example that we had, which was list node of 299. So this should get us 3, 0, 0, right? Which it does. if we take the case of just 9 that we mentioned, where we should have 1 0, that one also works. So we can see here this works fine. So that's cool. This is an iterative solution, so it's also a good idea to try to see if we can find a recursive one. So let's think about a recursive solution. So the idea of a recursive solution is that we need to find a base case, and we need to reduce the input size, and we need some operation that puts things together, right? That puts the reduced input size with the previous size, and so that we can aggregate and get a final result, right? So our base case here for a linked list, usually it's just if the head is nil, right? And if the head is nil, that means what should we do? We should just add 1 to that head, right? So we want to add 1 to a head that is nil. So that means we just need to return 1, right? That's the value of the node. Because we are adding 1 to something that is nil, which is pretty much just equal to 0, right? So the value is of the node value. So we can return 1. Now, how do we reduce the input size? So we just have a list node. The only thing we have access to is the next value. And so naturally you can, the first thing we should think of is we need to reduce it on add 1 to head that next, right? Now, how can we, what's the operation we can use? So what we are interested in mostly is whether there is a carry or not, and what's the value of the node. And so we want the carry and the value, so that for cases like, let's say 9 plus 1, we know that the carry is 1 and the value is 0, right? And so how can we obtain these two values? Usually we can obtain them by doing div mod of the head the val and 10, right? That's how we can obtain them. And so let's just see if we, let me show you for this, how can this work. So div mod of, let's say 15 and 10, that's just 1 and 5. So this is the carry and this is the value that we will set, right? So for a value, if that is more than 1 digit, we get the carry and we get this. So if we do +1 and then the value ends up to being something that is not 1 digit, we can obtain the carry that we need to use to go to the next node, and we can obtain the value that we need to set the current node to. And so to do that, here we can just have our operation be that, and we are going to set the carry and the head val or the node val to that, right? And that's pretty much it. We just need to not forget to handle the case where it's 9 plus 1. So handle case where there is an extra node, right? So for example, this one, we would need to have 1 to 10, which is 1 to 0. And so at the end of our recursion step, at the end of our recursion call, we need to handle this case. So let's call this A. Handle A, right? So that's pretty much it. So let's code that up. So let's call this one recursive. And so we need, let's have a helper here for our add node, and let's do the base case, which is if not node, return 1. And then otherwise we are going to say the node.val, we are going to add to do the recursion step, so we just add this one, right? And so the node.val will be whatever add.1, whatever recursive function, and in our case here it's add. And so head node.next. So we add that to the node.val, and then we check if this was like more than one digit, and so that we can have a carry. And so we do that by doing div mode on node.val and 10, and that way we get a carry and we get the real value that should be assigned to node.val. And so why is this? So this is basically, this may be like the node.val may have been 9, and then we return it 1 for the case where it's not node. And so we get 9 plus 1, which is 10. And so we definitely need to do this so that we can know that the carry is 1 and that the value is 0. Because if we do div mode of 10, that's 1 and 0. And now once we have the carry and the node.value, we can just return the carry. Why are we returning the carry here? Because for a case like 9, 9, we would do the recursion and we would assign these two to 0 using this node.val. But we still have the carry in the front, and we need to handle that, right? And this is an extra node, and so that's what we are going to do here. So the first thing, we are going to add one to node, and then that to head, sorry, and then at that point we would have the carry. But the head already changed so that it reflects, the 0, 0. And in case for 1, 2, 3, it would have already been done, and it will reflect 1, 2, 4. And so in that case, we don't need to do anything. So only if carry is equal to 1. And we have a head, of course, to handle a case where our head is like we pass null. We need to handle that case. And so for that case, we need to create a new node. Let's say this is the new head. Right, and this one starts out to be 1, and then we say new head.next is going to become head, and then the head is going to be the new head, and then we need to return head, right, so that it will work for all cases here. And that's pretty much it. So let's see if this one, let's use this one here. Okay, let's check our test cases. So 1, 2, 4, that's good. 2, 1, 3, 1, 0, 0. This one 3, 0, 0. And just to make sure that we still work with no case, so that one still works too. And that's pretty much it. Yeah, see you next time. Thanks for watching. See you next time. Bye.